Hello everybody, welcome back to another video in our C tutorial series. This will be my first video in a while. I've been busy with exams and whatnot. And today's video we're actually going to be discussing strings in C. Now I may have mentioned before that there is no string type in C. And that is true, but there is ways around this, of course. Now, first thing we are going to do is, of course, include our standard IO library, create our int main, just like every C program needs. Well, not the library, but you know what I mean. Now, we do have string literals in C. So, if we have something like this, my stack, you'll see why I named it that. And if I have this string, this is not valid, this is valid. And that is because basically what a string is just an array of characters. Remember, we have the type, we have a character, right? Now imagine we create an array, we have a character, 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 right? And if in each character we had our different letter, like this, and now you'll see why this is not true in a bit. Well, it is true, but you'll see why this format is missing something. But if we had something like this, well, as the programmer, we can interpret this as a string, because all we need to do is have some way to store this information, and when we do need to use the string, we just need to be able to extract it and treat it like the string that it is, right? Now, this is a string literal. And what we're doing here is we are creating an array of characters and we are putting it on our stack, correct? Now, remember, arrays and pointers are similar, but they're not perfect, right? So if I create this, and I also name it the exact same thing, right? You may think of these as the same thing. This is an array containing this, and this is a pointer to this, right? Now, this is okay, but if we really think about it, this is a pointer. Yes, it is on the stack, so we can modify it. But what do you think happens if we were to do this? Now remember, this is pointer arithmetic. We talked about it in the last video. This is just saying the first item that this pointer is pointing to, so it would be the H, and let's rename it to a capital H. Now, what do you think would happen? String.c. Oops. Strings.c. We never actually printed anything. Oh, but anyways, we got a segmentation fault, core dumped. What this means is we are accessing data that we are not supposed to be accessing. This pointer is actually pointing to a string literal, correct? But this string literal is actually stored, if you remember how our memory blocks look, these are stored in the text or data section. And they are marked as read only, so we can't actually modify these. But if we were to do that to my stack and go gcc strings.c .out, works perfectly fine. And just as proof that it works, we can go for int I is equal to 0, I is less than. Now for now, we don't know how to calculate the length, so we'll just go 5 because we know it's 5 letters, and we got to increment every single time, and we just printf %c. Now we go my stack add I semicolon, and let's print a new line. GCC strings C, A dot out, and we've capitalized it. So we know that works. Now, say for some reason we do want this, right? And we forgot that this pointer is pointing to read-only memory. And we were to do this here, right? Now, the issue with this is it actually compiles. And you might think, you know, that's a good thing. It compiles. That means our code is working. But it's worse for your program to fail compilation than for it to throw a segmentation fault while it's running, right? So as the programmer, we know that this is something that we don't want to modify. So we could throw this const. And this basically marks this piece of data as read only. And anytime that we try to modify it, it won't work. Now notice here, this is actually a pointer to a character that is const. It is not, so this is a constant character. It's not a constant pointer. So the order we read this is, it's like a spiral, right? So we go pointer to a constant character, if that makes sense. If we were to do it the other way, it would mean something completely different. It would actually mean now if we were to switch this and put it here, this would be a constant pointer to a character. And the problem with that is that would mean that the pointer itself can't be modified, but the character can, and we don't want that. Now, if we try this now, and we try to compile, we get a compilation error because it is read only, right? Which is good. Before we run the program, we know that there's a mistake, and we know that this is not something that we're allowed to do. If we go back, works perfectly fine. Now, one more thing about constant, well, not just pointers, any data type, because if we have an x here, an int x, if this is supposed to be some important number that we can't change, we can also throw a const. But since we can't modify it, we can't initialize it with no, we can't create the data type without it being initialized. Because, well, what does this mean? We already said that this is read only, so this is illegal, right? It's not allowed. So that's one thing to keep in mind when using const. You have to have a predefined value before you define the data. Now, we had a problem here, and that is, well, how do we calculate the actual size of this string, correct? Now, we could get rid of this for now. And if you remember, there is a sizeof operator. And here, we could just throw data types in it. And this will return how many bytes this takes. Now, remember, our string is actually just an array of characters. So if we have an integer size, and we take how many ever, let's say size of this array, my stack, right? And if we divide it by how many bytes are in one character, or in whatever is inside my stack, this should give us how many of this data type is in this data type, right? And we can print percent, I believe it's lu /n, and we pass size. Now, something interesting is going to happen here. Oh. Unsigned int. Well, this should say array, not stack, sorry. 6. Now, if we count this, it's actually 1, 2, 3, 4, 5. So what's the extra letter here? What's the extra character, right? Because we said that, let's say we create the same exact thing. We said that this is just a array of characters, right? L and then O. And if we were to do this exact same, let's just rename them. If we were to take the size now, well, what do we get? Whew. A lot of mistakes. Let's take this out. This out, my stack. Of course, we're missing brackets. We get 5 this time. So what's happening here, right? Now, one thing I didn't mention is that strings are null-terminated arrays of characters. And what does this mean? Well, it means that yes, we have all of our characters, right? We have characters in here, here, and here. But at the very end, we have a null character. And what this means is this just signifies how when our string ends. Let's say I had a separate function and this was an int size, right? And we want to pass a string to it, right? Or actually, let's do a print. And we are going to take this and we're going to print the string, correct? Now, what do we need for this letter here, right? We can actually instead just do string at I. So we want to continue until string at I does not equal to the null terminated character, right? And what we can do now is actually see if this works. So we want to print same, and this needs to be void. I believe that is all. What's our error? Spelt it wrong. Oh, forgot to remove this stuff here. It's able to print it. Now we can also have in our we don't want to include the print new line in the function. We want to leave that to the user, right? The user can decide that, oh, I want a new line after. Now I hope this makes sense, because what this means is that this is just an indicator for any program to know that this is the end of the string, and we can really test this, right? If we were to include 2 of it, what do you think would happen? So let's say I had H E L L O, and of course we need our null terminator. And let's say we put another word. Let's put A N D. Now think about it. If I put another null terminator here, what do you think printing this will do? What do you think it should do? Prints hello, right? But if I were to simply omit this and change it to something else, just what is, oops, let's put this. If I were to change it to this, what makes the most sense? Well, it prints both. And that's because it won't stop until it finds the end. Now, C has its own library, and it's called string.h. And remember our problem before when we were calculating the size of the string, we got one extra one. Well, they actually, here, we could just go I is less than. They have a str length function, and we can pass our string into here, and we can write that really quickly after. I believe that is correct. Yes. Now, if we were to write our own version of this length, well, an integer, call it size, and we will pass a string again, and we are going to have some integer I, set it to 0, and we're going to go for character C is equal to string. Actually, we don't even need to do this, I believe. We can go as long as string I does not equal to the null terminator increment I, and just return that I. And now, if we, instead of this, we use size, we'll see if this works. Oops. This should be a semicolon here. It works perfectly. And, well, that is all for strings. It's a pretty short topic. The most important part is to remember the null terminator at the end. And yeah, there's a bunch of other string functions in this library that are very useful. Like there are some that you could use to replace certain parts of the string or compare or whatever you need. You can look up documentation and see whatever fits your needs. Thank you guys for watching, and I'll see you guys in another video.